Now,
We're not getting
all right, so when we solve equations, let's just go back to linear equations, okay? We've got some opposite operations. If I had 5x equals 20, that 5 is being multiplied to the x, so what do you do to get rid of it? Divide. So multiplication and division are opposite operations. Do we agree with that? It makes them cancel out and go away. How about if this was x plus 5 equals 20? Subtract it, right? Well, come on. So addition and subtraction are opposite operations. So my question is, that's addition, subtraction, multiplication, division. What if I have something like this? Actually, let's make it 20 since we've been sticking with the 5s and the 20s. What if I have something that looks like that and I need to get rid of that exponent? What's the opposite operation of a square? Square root. So to get rid of it, I square root. Does that make sense? Anytime you have a squared and a square root, they cancel. So I have plus or minus. Now, I don't want to leave it like that. Why? You do know. This is easy. What can I do with it? I got to what? Say it again. Well, I can have the radical. Somebody said it. Simplify it. 4, 9, 16, 20. Let's see. 6, 7, 8, 9. Guys.
the same thing?
No, we're just getting started. All right. So when I simplify, which is what I need to do every time I see a radical from this point forward, is I need to look at this list of perfect squares and say, can I divide it evenly by one of those? That's right, 4. Okay. So I could split this up, and this is what we were doing yesterday. 4 and 5. 2 root 5. And some of you yesterday were getting a little mixed up on when to drop the root and when not to. So the perfect squares and when you drop the radical on and write what it equals. Okay? When I can't divide by anything else, I leave that 5 there. So of course, it's not going to be this easy every time, right? It never is. I'll give you a second. If we can rewind for just a second back to linear equations, and I'm going to look at like a 2-step equation. If I have something that looks like this and I need to solve it for x, okay? You do, but my question is, how do you know what order to do it? Like, how do you know to get rid of the 5 before you get rid of the 2?
PEMDAS.
You're actually close. It's backwards PEMDAS. So it's SAD map when you solve. Nobody ever taught y'all that?
Yes, we do.
The more complicated our equations start to get, the more you need to rely on going backwards PEMDAS so you can figure out what you need to do, else you get the wrong answer. Okay? So if you look, parentheses are always last. You start with addition, subtraction, and that's why I move the 5 first. So to move the 5, what do I need to do? Subtract it. So subtract 5 from both sides. That doesn't cancel. So I get 2x equals 17 minus 5 is 12. Okay. Now I can move on to the multiplication, division, and I can divide by 2. So I show you this example because now we're adding a piece that you haven't had before. We're adding an exponents piece in here that you're going to have to use to solve.
Is that an E?
That is an E, yes. All right. So couple things you got to remember. You got to remember how to simplify your radical. You got to remember how to rationalize that bottom when there's a radical in the bottom. And you got to remember that plus or minus. Okay? So the opposite, to get rid of the squared, we're going to do square root. So let me show you an example. And anytime you see, no matter what else is in the equation, if you see x only one time in the equation, you can always SAD map your way out of it. So this is an example. This looks very similar to the last one. The only difference is this exponent on that x, right? What do I do first to solve for x? Subtract 5. What is 41 minus 5? 36. Good job. Now, should I take the square root or should I divide by 3? Why? It's next. Multiplication division is next. So I need to make sure I do that next. So divide first. What's 36 divided by 3? 12. Anybody confused so far? Only difference is that little exponent sitting right on there, right? How do I get rid of that little exponent sitting right there? Square root. This is gone. So now my question is, am I done? Why? I need to simplify it. What can I take out of 12 that is a perfect square? 4 times what? 3. So I get a 4 and a 3. And I chose these two numbers because one of them is a perfect square. Okay? So what is the square root of 4? 2. The square root of 3 stays because it can't be simplified anymore. So I'm done. Does that make sense to you?
We need to keep that.
Just keep that. You know it's going to get a little bit harder than that. Look at this one. If you keep SAD map in your brain, you're going to be okay. It's got to be SAD map. And this only works whenever we see x only written one time. And I keep saying that, but think about our quadratic equations where I'd have like 2x squared plus 5x plus 3 equals 0. And actually this minus. And so I could factor it and set each piece equal to 0, right? But if I were solving this, I couldn't SAD map this because x is in here twice. Okay, the only ones you can SAD map is when x is only in there one time. So for example, 7. Oh, now I got some parentheses in here. Do you see what I'm talking about x only being in here one time? There it is. There's the one time it's in the equation. So that lets me know, hey, I can use SAD map to get my way out of here to solve it. So, remembering that parentheses are last, and anything inside those parentheses are last, what do you think I do first here as I solve it? Add 18. Because I want addition and subtraction outside of the parentheses. All right, so on the left I have the 18's gone. What does the right side become? 28. All right, so I've done my addition subtraction. That's exactly right. Next is multiplication division outside of parentheses, so I'm going to divide by 7. What, by the way, if that had been a fraction in front instead of a whole number, what would you have done? If this 7 was like 1 over 7.
You would have traded
Multiply by reciprocal. Flip it over and multiply. Don't try to divide by a fraction. Multiply by reciprocal. All right, 7s are gone. Yay, x minus 4 squared. 28 divided by 7 is 4. That's the multiplication division. What's next? Exponent. How do I get rid of it?
What was subtraction? Was
You sure?
yes, ma'am.
Okay. So the square root's gone here. What is the square root of 4? Or negative 2. It's actually plus or minus 2. It gives us two answers, okay? Remember when we factored and we set each piece to 0, we got two answers. We get two answers here a lot also. Now what? Add 4, right? So plus 4. Now, don't make this 6 because it's not 6. That's one of the answers. Understand what this means. Plus or minus 2 plus 4 means positive 2 plus 4 or negative 2 plus 4. You can't combine them like that at first, okay? You got to split that up. So this would be 6 or 2. Does that confuse anybody? So the question was, could you leave it here? A lot of times you're going to get to this point, and this might not be a perfect square. What if that was square root of 5? Okay. So at that point, you might have something like plus or minus square root of 5 plus 4. And you can't combine those or do anything else, so you would leave it just like that. So long as you understand that it's two answers that you're getting, it's the positive and the negative side of it, then that's fine. Other questions about that? Fractions, here's a fraction, but still I only see one x, right? So I'm going to SAD map, get x by itself.
Are we gonna have any today when there's two x's?
No, these will all have just one. Everyone today will be a SAD map problem. What's the first thing I need to get rid of?
Do the reciprocal.
The 1 over 5, the 1/5, right? So I don't want to divide by 1/5. Can you put that away from me, please? That's kind of rude. Okay. I don't want to divide by a fraction, so rather I want to multiply by the reciprocal on both sides to get rid of it. Yes? It's going to cancel on the left. Right? X plus 3. That's why we multiply by a reciprocal, is because it does cancel. How about the right? 35. Yes or no? If that had been 2/3, then I'd be multiplying by 3 over 2. Whatever it is, I flip it over and I multiply. Right? Your calculator will do that for you. Let it. Kobe, you're not asleep, are you? This fun stuff. Okay. What do I do next? Square root. Okay? I promise I'm almost done. I know I've held your attention about as long as I can. Plus or minus square root of 35. Is there a perfect square I can divide 35 by? Look at this list of numbers in black. No. So it's already simplified. Leave it alone. So what do I do now? Subtract 3. So I get plus or minus the square root of 35. And John, this is one like I was telling you. I can't combine it, so I write it. Does this make sense to you? Just as a reminder, you may get to a point.
Should I maybe 3 be under 3 pi?
No, because you can't combine them, so you just write them beside each other like that. You very well may get to a point with something that looks something like oh, yeah. like this. How do I get x by itself? Square root it. Now, when you square root this, what's the problem on the right? It's a fraction. I've got a square root and a fraction. I can't have a square root where? On the bottom. The bottom's the problem. How do I get rid of it? That's right. So what am I multiplying the top and the bottom by? Right? So I've got x minus 1. This is my plus or minus because this is my radical part. Up top, I have the square root of what? You can do this. Square root of 2 times square root of 3 is square root of 6. What happens to the bottom?
Square root of 3.
Well, square root of 3 times square root of 3, it's just 3. Right? And you leave it. But I got to move that 1. Okay, so it's just plus or minus square root of 6 over 3 plus 1. So you see how we have to use what we talked about yesterday to finish up what we're doing today. Does that make sense? We kind of learned that yesterday to be able to do what we're doing today. All right.